Welcome to Mac 1140, Exam 2. This is problem number 3 of the tear-off section. In this question, they go ahead and they give you the function x squared plus 2, and they want you to go ahead and limit its domain so that way x is less than or equal to 0, so that way we can go ahead and find an inverse function. And then they want the domain and range of that inverse function, and then they want us to graph it. So, because we can see that this function, x squared plus 2, is just a parabola, and clearly it's a function because it passes the vertical line test, but we know it's not an inverse function if it doesn't pass the horizontal line test, and clearly it fails it right now. So that's why they go ahead and they stipulate that you need to restrict the domain. So if we choose x to be less than or equal to 0, that essentially gets rid of this leg. That's no longer there, and we just have this portion. So if we just erase this, that's what this function with this domain restriction looks like. And now we can see that it still passes the vertical line test, so it's still a function, but it also will pass the horizontal line test, so therefore it's going to be an inverse function, or it's invertible. So now we want to go ahead and just take the inverse of this function. So how do we take the inverse? Well, we just switch the x's and y's, and we try to solve back for y. So we could write this as, first it's just y squared, or y equals x squared plus 2. So we flip the x's and y's, so we get x equals y squared plus 2. We can subtract the 2 over, and then we can square root both sides. So you'd have the square root of x minus 2 equals y. Now when you take the square root, you get a plus or minus. But we have to choose which branch to go with. And then that's where this domain restriction comes into play. We say that x needs to be less than or equal to 0. Now let's think about this, how we can determine if this is going to be a plus or a minus. Well, we know that if you were to graph the inverse of this, it's just mirroring over this line y equals x. And we're going to have to graph it here in another part of the question. But so if this is the original function and you were to mirror this over that line, we can anticipate getting something that goes like this. So if you get this function, you can see that that looks like it's a square root function, but it lies below the x-axis instead of being above. So that's going to tip us off that this should be a negative. And then you can also see that x is less than 0, so that means x's are negatives, so you'll end up getting a negative sign down here. But I mean, the real reason is that we're actually flipping down, and then the branch here, this is the negative branch when it comes to the range of the original function. So you're going to get the negative branch when it comes to, this is the negative branch when it comes to the domain of the original function. So you'll get the negative branch when it comes to the range of the inverse function. So we have negative square root of this, not plus or minus. So this is going to be our inverse function. So we can just fill this out up here. Then they ask you for the domain and the range, and then they want you to graph it. And we can see that our graph here makes sense. We said that this was going to be our original guy. Our inverse is supposedly this. Well, what does this look like? Well, we know the square root of x just looks like that. Then we have a minus 2, so that's actually going to shift it 2 units over. And then we have the negative out front, which is going to flip it over the x-axis. So we get down to this. So what we predicted is actually what the answer was. So now that we actually have it graphed, it's easy to go ahead and find the domain and range. We can see the domain is just going to be from 2 all the way to positive infinity. And you're going to be including 2. 2 to positive infinity. And the range is just 0 to negative infinity. But you'd actually want to write that as negative infinity to 0 and bracket it. And then we can see that the domain of the original would be the range of the inverse and the vice versa. So we said the domain here is 2 to infinity, and we can see the domain, this is the domain of the inverse. So that should be the range of the original, and we can see that. It's 2 to infinity. The range here of the inverse was negative infinity to 0, so that should be the domain of the original, and we can see that's the case as well. Negative infinity to 0 is the domain. So this checks out with what was anticipated. The graph matches up with what we anticipated for the inverse, and this is it. This is your final answer.